Okay.
Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. You're done?
Done. Hey guys, hope you're still doing well. Today we're gonna go over your wavelength practice. So on the calendar, what that looks like is your May 26th stuff. Hopefully you've been keeping up all right with the other assignments that I gave you. Those were just assignments that had instructions at the top. I didn't go over them with you, but I have been getting all your questions, and hopefully that's been an okay way to do those. But this will be our last video for the school year. After you finish this, the rest of the time is just in there for you guys to catch up with any missing work that you might have. Your test will be available on Schoology probably sometime either Thursday or Friday of this week, and then that will be open through the weekend. But this is our last video to show you guys what your assignment is. This is what was shared with you, and I have two equations up at the top. Let me move me. Where shall I go? There. You have two equations at the top. The first one is called, I want to talk about equation 2 first, actually. It's called other waves, and this is our general equation that I gave you the triangle for. So this one says that wave speed is equal to wavelength times frequency, and I gave you the different variables for each of these. So your wave speed will be given to you as a variable of v, your wavelength will be in this upside down y or lambda, and then frequency is in f. And then I gave you your labels, so meters per second, meters, and hertz. And then if you look at this equation 1, it's the same setup, it's just given for the speed of light. So it's specific to light waves. So anytime in your homework, if you're talking about light, for example, number 1 says a photon has a frequency of da-da-da-da-da-da. Photons have to do with light. So you will be using your first equation to solve question 1. And we know that light travels at a speed of 3.0 times 10 to the 8 meters per second squared. That is in scientific notation. So if I were to put that in standard form, I would be moving that decimal 8 spots out to the right. Then it's still lambda and meters and hertz. So the only thing that changed there was I know my speed. So if you are given two variables in any of your equations or any of your problems, that means that you'll be using that first equation and you'll be solving for that third variable. But if you're only given one variable in the word problem, that means you're going to be working with the speed of light. So if you can't identify that a photon has to do with light, the other trick is to look at how many variables they give you. I'm going to work through two problems with you. I'll work through a light waves problem as well as an other waves problem. But with the triangle here, it should be pretty easy. It's what we've been doing all of our math problems, or how we've been doing all of our math problems. So let me get you over here. So just to copy down my triangle, I've got V for wave speed, my lambda for wavelength, and my frequency. And I'll just do the first problem, which says a photon has a frequency. So if my frequency is going to go in my frequency box of 2.68 times 10 to the 6 hertz. What is its wavelength? So I'm looking for this here. And you'll notice that we're only talking about one variable, and I'm already asking the question. So what that means is that I should know what my wave speed is. And since this is a photon that's dealing with light, I know that my wave speed will be that constant. So that will be a 3.0 times 10 to the 8th. So from here, it tells us our equation, which is just to simply divide these two out. So when I convert these to standard form and punch them into my calculator, I get a answer of 111.94, and our label on this will be in meters. So that's how you do problems that use equation 1. And again, equation 1 has to do with light, so if you have any clues in the wording and you understand that you're talking about a light wave, you know to use equation 1. Otherwise, if they only give you one variable, you can assume that you're dealing with equation 1, and then you have to put in the speed of light as a constant. Your other example, see here, that you will see has to do with waves that don't deal with light. So like this one is dealing with a sound wave. So we'll do number 5. And just to kind of give it away for you, the first 4 questions have to do with light, and then after that, I believe they're all others. And then there's just some general questions about the two. So I'll do number 5 as an example. It says calculate the speed of sound with a wavelength of 10 meters and a frequency of 50 hertz. So to show you what I'm doing here, so that was number 1. We'll do number 5. If I set up my triangle again, I know that I have a wavelength of 10 meters and a frequency of 50 hertz. And so all I'm going to do for this one is I'm going to be multiplying. And so that one should be pretty easy. 500, and that is going to be in meters per second. So these shouldn't be too difficult. Like I said, there are 2 different types of equations that you're using, light waves and other waves, and then the last 2 questions have to do with just answering what's happening in general. So if I were to increase one, what would happen to the other? So you'll have to play around with some variables there. But if you have questions for me, as always, please feel free to email me.
Science science science